Okay. Good morning, students. Today we discuss the modern periodic table. Modern periodic table is the classification of element. Classification of element depending upon its frequency and atomic number. Modern classification is based upon two things. First one is the electronic configuration and second is the atomic number. Groups and period. Modern periodic tables are classified into groups and periods. You can see here in the periodic table. Okay, first, second, third, fourth, fifth, sixth. So 7 periods are there. In this 7 period and 18 groups are. So here we have total 7 periods. And total 18 groups are there. In that first and second is the S block element. Similarly, 13 groups, 18 it is P block element, and in the middle 3 to 12 is the D block element. It starts from D block. This is P block and this is S block. So you have to remember the modern periodic table is classified depend upon its atomic number. Physical and chemical properties of the element are periodic function of their atomic number. Remember atomic number. Second thing is previous till 94 natural elements are there and other are man-made elements. Classification based upon atomic number and electronic configuration. Classification of this periodic table is depend upon atomic number Z and electronic configuration. Long period of periodic table containing 7 periods and 18 groups. Similarly, electronic configuration is in same group. So, in the outermost orbit, element having similar electronic configuration or valency, they are there in same group. So one by one we discuss the elements. Which are the elements? Suppose in the S group, if the particular element having 1 or 2 extra electron in the outermost orbit in S orbital, then it is kept in S block. So on the left hand side, S block is there. First and second group belonging to S block. Similarly, P block 13 to 18, it is known as P block. 18 number last one, that is the inert elements. So one by one we discuss. In the middle we have transition element, that is B block and F block. We throw some light on periodic table how it is arranged. So first one, that is the hydrogen. Atomic number 1. Atomic number 2, that is helium. This 2 number helium is kept over here in inner area. Why? Because orbital having outermost orbit completely filled, they are known as noble gas. So it is kept over here. 2 number is here. Third number, having 1 extra, that is lithium. Hydrogen and helium. Hydrogen symbol is here. Similarly, these elements are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So similarly, these elements are elements. Second group, there is no elements in first group. Why? Because in first principal quantum number or first orbital, first circle, only 2 electrons are there. So 2 elements is there, hydrogen and helium. Second circle, that is lithium, 8. Configuration is 2 and 8. So total up to 10 electron can be filled. So its nomenclature in S block. S block, that is known as alkali metal. It is known as alkali metal. Remember the name alkali. S block means alkali. Second group we discussed, that is the second group. That is alkaline earth metal. It has a valency 2. So it starts from beryllium, okay, magnesium, calcium, strontium, barium and radium. Again I revise: beryllium, magnesium, calcium, strontium, barium, Ba and radium. All has a valency plus 2. Remember this. Second here, representative element, this P block. It is known as representative elements. One by one we discuss the elements of this P block. P block starts from this second period. So here number is 3 is lithium, 4 is beryllium, number 5 is starts. So boron family. 6 number is carbon family. 7 number is nitrogen family. Oxygen family, fluorine, and last one is the neon. So one by one from 13 to 18 we discuss the elements, and you have to remember it has the same electronic configuration. Okay, and it is known as representative elements. So one by one: boron, aluminium, gallium, indium, helium. Boron, aluminium, gallium, indium, helium. Second is carbon, silicon, germanium, tin and lead. 14 group elements: carbon, silicon, germanium, tin and lead. 15 group element: nitrogen, phosphorus, arsenic, antimony and bismuth. Again I revise: 15 group element: nitrogen, phosphorus, arsenic, antimony, bismuth. Similarly, oxygen means 16 group element: oxygen, sulfur, ceruleum, tellurium and polonium. Oxygen, sulfur, ceruleum, tellurium and polonium. Halogen family, 17 group element, that is known as halogen family. Its elements are: it is electronegative element, only one electron is required to complete the octane, so its valency is minus. Now negative valency, so it is minus 1 valency. So fluorine, chlorine, bromine, iodine, Std9. Fluorine, chlorine, bromine, iodine, Std9. Similarly, last element, that is 18 group element. 18 group element, that is noble gas. So you have to remember all electrons are completely filled in the outermost orbital. So helium, neon, argon, krypton, xenon and radon. Again I revise the elements: helium, neon, argon, krypton, xenon and radon. And you must know the atomic number of this inert element. First one, it is 2. Remember this number. This series you have to remember, so you can remember the atomic number of all the other elements depending upon the inert gas. Helium, neon, argon, xenon, krypton and radon. So it is 2, 10, 18, 36, 54 and 86. So remember this number: 2, 10, 18, 36, 54 and 86. Similarly here in the middle, okay, d orbital, that is known as transition elements. 3d and 4d. Transition elements. Transition elements start here from 21 to 30. And here it starts from, okay, it starts from 4d. So it is here onwards. Up to here it is 30, 36, 38 to 47. So these elements are there. Similarly, in this element here, then below element, if 3d is filled after 4s, so you write here, one thing is there, here you have to write it come 4, then it is come 3d. If it is 5, then it is come 4d. Similarly, if some 6, then here 5d, 6d, and here another, that is f orbital will come, 4f and 5. So this thing you have to do. F orbital, that is known as inner transition elements. F orbital elements, there are 14 elements. They are known as lanthanide and actinide series. Remember this, lanthanide and actinide series. That is known as inner transition elements. So in this way, modern periodic table is classified. Here you have to remember this number, that is 21 to 30. 3D orbital. 3D orbital 21 to 30 means scandium, titanium, vanadium, chromium. Scandium, titanium, vanadium, chromium. Manganese 25. 26, that is iron, cobalt, nickel, copper, zinc. Iron, cobalt, nickel, copper, zinc. Zinc, it is 30. So you have to remember elements 21 to 30 because transition chapter is there, D block, F block. You have to remember, and in coordinate chemistry, in complex compound, you have to remember all these number and how electron transfer is taken. So again, in short, I revise periodic table depending upon the outermost electronic configuration and atomic number Z. On this side it is S block, two groups are there, 1 and 2. This side P block representative from 13 to 18. In the middle from 3 to this D and F block is D block starts from this 4th period, and if D block starts then one number less, N number less, so we start from 4, 3D. Similarly for then OD. F block starts from 6 and 7, F block. Okay, 4F and 5 transition elements. So in this classification of elements is there. In next period we will discuss about the nomenclature of remaining man-made elements. If elements are discovered more, then its name is not given, but depending upon the modern nomenclature, the temporary name is given to that particular element. But that nomenclature we will discuss. Okay, second thing we discuss about how to do nomenclature of the element, undiscovered elements. Okay, more than atomic number 100. So one by one we discuss the element. Certain numbers have certain abbreviation is given according to IUPAC nomenclature, International Union for Pure and Applied Chemistry nomenclature. If the digit is 0, then its name is given nil. Okay, abbreviation given is nil and symbol is N. Similarly 1, then it is Un, symbol is U. If it is 2, then it is B, billion, remember this, and symbol is B. If it is 3, then trillion, so it is T symbol. Number 4, quadrate, well, quadratics, so it is 4 side, so quadrate symbol is Q. 5, then organic compound, remember the pentane, so that is pent, symbol is P. 6 number hexane, so it is hex, symbol is H. 7 septane means 7, symbol is S. 8 means octane means oct, remember O symbol. 9 it is nonen, instead of that it is written NN. Okay, nonen, remember the 9 means what? It is nonen, inorganic, but remember NN means E, symbol is E. With the help of this we try to give name or nomenclature of atomic number greater than 100. First one, 101. If it is 1, then you have to use the symbol Un. So you have to write Un. If it is 0, second digit is 0, so it is nil. So it is nil. Un, nil. And again 1 is there, so it is unium. Remember this. Okay, unium. Its symbol is short. 1, then it is U. 0, then it is N. And again 101. So again you have to write symbol. Okay, again you have to symbol. First one is U. And U. Name is unilnium. Similarly, 102, then it is nil. Second is B, so it is billion. Symbol is U. 0 means N, and billion symbol is B. Similarly, you can write symbol for all the elements. I am writing symbol for 105. 105 is un. 0 means nil, and 5 number means pen. So it is pentium. Nil pentium, and symbol is un means U, nil means N, and pentium means P symbol. Last one, 100 and up to 18 we can write, but we take the example that is of 1, 1 and 3, so 103. So it is un 3 number means trium. Untrium. Symbol is U, and trium means it is T. So in this way you can do nomenclature, and this is the symbol, abbreviation and symbol. Similarly, last is 110, then nillion, nillion. So you can write U and N, nillion. So similarly, you can write these abbreviations for all the other elements which are discovered artificially, whose atomic number is greater than 100 by this method. So this way you can classify elements whose name is not given. Then after those who have discovered, that name is given to that particular atom or elements. The scientist who have discovered, and he gives more of its contribution to that particular element, then his name is given in a periodic table. Okay, try to learn this nomenclature and modern periodic table. Okay, thank you.